In this video, we are going to continue with multiplying radicals, and we're going to do problems numbers 18 through 21 from our notes. So if we take a look at number 18, we have two parentheses touching. That means multiply. Since we have two terms multiplied by two terms, we are going to go ahead and FOIL this. So we're going to multiply all the terms together. So I'm going to start with the first one, and I'm going to multiply it to the first term here. So if it helps you write it out, we have 2 rad 3 times rad 3. So when we do that, we're multiplying. These don't have to be the same. They just happen to be here. So we'd have 2 times, there's no number here, so there's like a 1. So 2 times 1 is 2, and then square root of 3 times square root of 3 is 9. And then the square root of 9 is 3. So we would get 6. Okay, now we're going to do 2 rad 3 and distribute it over here to the negative 2 rad 5. So we'd have 2 times negative 2 is negative 4. And then we are allowed to multiply even though these don't match. So 3 times 5 is 15. And then that is completely simplified because none of these numbers can go into 15. So we can't simplify the square root of 15 any further there. So we would have now minus 4 rad 15. So we're done distributing the first term. So now we have square root of 5 times square root of 3. Again, when we multiply, these don't have to match. So 5 times 3 is 15. And again, we can't simplify square root of 15 any further. And so this is a positive square root of 15. And then lastly, we have the square root of 5 that has to be distributed to the negative 2 square root of 5. So there is no number here. It's a 1, because you can multiply 1 to anything. So 1 times negative 2 is negative 2. And then we are allowed to multiply radicals as long as their index are the same. So square root of 5 times square root of 5 is square root of 25. And then the square root of 25, what times itself is 25? This would make 5. And it's right next to this, so that's multiply. So we get negative 2 times 5, that's negative 10. Okay, so now the multiplication is complete. And now it's an addition and subtraction problem. So in order to add or subtract, they have to be like terms. So we can combine these two terms together because they have the same index and they have the same radicand value here. So we have negative 4 plus 1. That's negative 3, and then we keep the radical 15. And then we can combine the 6 with the negative 10, and that would make negative 4. So the negative 4 can go in the front, or we can write our answer as negative 3 rad 15 minus 4. So either of these are okay. This is my favorite, because when you're typing this in, if you're doing online homework, if the negative 4 goes first, it doesn't accidentally get stuck inside this radical. So this negative 4 is not in the radical, so sometimes when people write it second, it gets mistaken for being in the radical. So either one of these is fine. And so again, we could always check this by typing this into our calculator and making sure that it gives us the same thing as this. So for instance, we could do 2 times the square root of 3 plus the square root of 5, close the parenthesis, another parenthesis, square root of 3 minus 2 times the square root of 5, and then we could jot down it's about negative 15.61, etc., etc. So now if I enter this in the calculator, I'd have negative 4 minus 3 times the square root of 15, which is the same decimal we got when we entered this in. So then we feel good about our answer. Okay, so let's check out another problem here. So we have an exponent outside of parentheses. So we've learned in previous chapters that we are not allowed to distribute the exponent. The only time we're allowed to distribute the exponent is if it's a monomial, so just one term, so this plus can't be there. So for instance, if the problem looked like this, then since this is all together by multiplication, this we can distribute, and it would be 4x, and we multiply exponent. But we can't on problems that look like this. You cannot distribute, no. So to do this problem, just like we've done in previous chapters, we have to write this out twice and FOIL, multiply everything. So when we do that, we'd have 2 times 2, so write it out if you need to see it. So 2 times 2 is 4. And then we'd have 2 times radical 7. You can't multiply these because this is 2 times some decimal. So if you do 2 times 7, that's not 7. This is some decimal number. So we're just going to bring it down as positive 2 rad 7. So now we're done with the 2. So now we're going to multiply radical 7 times 2. So again, we can't multiply the 2 and the 7. So we're going to bring it down as positive 2 rad 7. We always put the number in front of the radical when we multiply, just like when we have 2x, we don't leave it as x2, right? So we put that number in front of the variable, we put the number in front of the radical. That's just how we do it. All right. Then lastly, we have the square root of 7 times the square root of 7, which is the square root of 49, which is 7. So this would make a positive 7. So square root of 7 times square root of 7 is the square root of 49, which, what times itself is 49? 7. So now the multiplication is done. Now it's an addition and subtraction problem. So we can combine our like terms. We have a 4 and a 7, that's 11. And then we have 2 rad 7 plus 2 rad 7. So remember, we're going to do 2 plus 2, which is 4. And then the radical 7 stays. You can also write your answer as 4 rad 7 plus 11. This one's better because it doesn't look like the 11 is in the radical. Now, come exams, what do I see people do? I'll see people add 11 plus 4. You can't do that because this is multiplication, and multiplication in order of operation comes before adding. So if you add these, you didn't follow order of operations, which would say to do this computation first. So you are not allowed to add these. You can only add with radicals if they match. These don't match. That's it. That is our final answer. Alright, let's go ahead and check out number 20 here. So there is a shortcut to this problem. From a previous chapter, we talked about conjugates. And when we multiply conjugates, so for example, x minus 4 and x plus 4, some of you think of it's like a difference of 2 squares, right? When we multiply these, the middle is going to zero out, and all we're left with is x times x and then negative 4 times 4. So the shortcut is I could just do 2 times 2 and square root of 7 times negative square root of 7, so negative. A positive times a negative is a negative, and then 7 times 7 is 49. Again, if you don't understand or see that, you could just multiply this out. 2 times 2 is 4. 2 times negative 1 is negative 2, and then rad 7. And then over here, we're going to have a positive 2 rad 7 when we multiply these two. And then a positive times a negative is a negative. And you could see why this term applies, because these two right here will make 0 rad 7. There will be 0 rad 7. So all we're left with is this 4 and the negative square root of 49. So again, we don't have to do this work because we can notice they are conjugates. They are exactly the same, except one's a positive and one is a minus here. So now to continue this, the square root of 49 is 7, and then 4 minus 7 is negative 3. So our final answer is negative 3. Now for our next section in 8.5, this is going to be very important. It will be why we're going to do what we do in the next section of notes. So notice when you have conjugates, your final answer here does not have any radicals in the final answer. So when you multiply conjugates, notice your final answer, that will always happen. There will be no radicals left in your final answer. So for example, this problem here, there is a radical left because these are not conjugates. They're not, one's positive, one's negative, and everything else is the same. So just keep that in mind for the next section. Alright, last problem here. So we're multiplying, since the index are the same, we can multiply these, or we could try to simplify them individually first. It's up to you. I'm going to go ahead and go straight across, since the numbers won't be that big. So 2 times 12 is 24. And then remember when we multiply, so when we do 2x to the 7th times 2x to the 4th, previous chapter we know to add exponents when we multiply. So now I'm going to simplify this. So square root of 24, I know that that can be simplified because I know that 4 can go into 24. Or you can use a factor tree and pick any two numbers you want. Trying to mix it up and use both methods in these videos. So since the index is a 2, we're looking for two that match, so like this one and this one, but only one makes it out. And then these two are stuck inside. So we get 2 rad 6. And then to do the exponents, since there is no number, it's a 2. 2 goes into 11 5 times. So that's how we know we're going to have x to the 5th here. And then the remainder is 1. So we're going to have 1 left inside. So we get 2x to the 5th times the square root of 6x for our final answer.